Lesson 43, solving systems of linear inequalities. So these are very similar to solving systems of linear equations, but for the time being we're just going to deal with two variable equations, because three variable equations will make this very difficult. So we're just going to jump right into it. Example 1. Oh, I'm zoomed in here. Zoom out. There we go. Example 1 says determine whether 2, 1 and 2, 2 are solutions for the system of linear inequality. So we have y is less than 3 and x plus 2y is less than or equal to 4. So in order for a point to be a solution for a system, it must be a solution for both pieces. Okay, so if I plug in 2, 1, I need to take it and put it into both pieces. So here, when it says y is less than 3, I'm going to plug in 2, 1 for that. So my y is 1. Is 1 less than 3? Yes or no? It is indeed. Then I'm going to plug it in for this one. I have 2 plus 2 times 1, which is just 2, is less than or equal to 4. So 2 and 2 make 4. So is 4 less than or equal to 4? Indeed it is. So it is a solution for the first point. So here, yes it is. I'm going to check it for the second point. I'm going to plug it in this piece for the y. So is 2 less than 3? It is indeed. Is 2 plus 2 times 2, which is 4, less than or equal to 4? 2 and 4 make 6. So is 6 less than or equal to 4? No. So it is not. So this one is a solution and this one is not a solution. Okay? Anybody got questions on that one? Here's the biggest confusion thing that I see. People see y is less than or x is greater than or something, and they say, well, I can't plug in both of the numbers, so what do I do there? Right? Okay, so continuing on, example 2. So graph this system of linear inequalities. We're going to do this one by graphing, and we're going to show where the answers are. I'm going to use two different colors so that you guys can see it a little easier. I will use purple and green, I guess. So the first equation says 3x minus 4y is greater than 8. Next equation, I'm going to write them side by side because I'm going to have to manipulate them here in a second. Y is greater than or equal to 3/4 x plus 1. Now this one's easy to graph. It's in y equals mx plus b form, so it's really easy to mess with. The other one, however, is not as easy to mess with. If I didn't want to convert it to y equals mx plus b, how could I graph this? Somebody say intercepts? Intercepts, yeah, that's good. So if I wanted to graph this one without having to manipulate it, I would solve it by using the intercepts. And just to remind you, that's using an x and y chart with a staggered set of zeros. Okay, you can do that. That's perfectly fine. If you do want to put them both into y equals mx plus b, then we just have to solve them as such. So let's start. We would subtract 3x from both sides. So that one's gone. I have negative 4y is greater than 8 minus 3x. Now this is the reason why I don't particularly love for you guys to do this, because we forget about a negative. Well, we don't switch the sign. So as a note, remember that if you multiply or divide by a negative number across the inequality, then we have to change the direction of our sign. Okay? So before it was greater than, now it's got to be a less than symbol. When we multiply or divide by a negative number across an inequality, we must change the direction of its sign. Now if it's an or equal to, it still stays an or equal to. We just change the direction. So here I'm left with y. Here I have a negative 2 now, and I have a positive 3/4 x. So here are my two equations. I have y is less than negative 2 plus 3/4 x, and I have y is greater than or equal to 3/4 x plus 1. Now I can already tell something about these lines. What do I know about them? They're the same slope, right? So they are what? Parallel. But that doesn't necessarily mean that there's no solution yet. So we have to actually graph these. There's a negative 2, so I'm going to go down 1, 2. There's my negative 2. I'm going to go up 3 over 4. It's positive, so 1, 2, 3. 1, 2, 3, 4. And then I'll graph that with a dotted line because it's an or equal to, it's non-inclusive, so it's dotted. Okay, so that's the best dotted line I can do, I guess. And I put sets of arrows on it because it continues forever. The next line, this is an or equal to, so it'll be a solid line. It's up at positive 1. I go up 1, 2, 3, and then I will run 1, 2, 3, 4. And again, to double check yourself, you'll end up with a parallel line, so we already know that much. That one's a solid. So again, those get arrows. So here's the part that's different. Everything else has pretty much been the same aside from that when we multiply or divide by a negative number across an inequality part. Everything else has been the same. What I need to do now is I need to figure out which direction to shade. Just like we learned to graph inequalities, we still have to graph them with shading. So to do that, I'm going to make my colors here. My Y is going to be this one here because I labeled it purple. This Y will be the green one, so I'll make it green. Okay. So I like to run the test point 0, 0, if at all possible. Now, so long as 0, 0 is not on the line that you're trying to use, or you're trying to test, that's fine. So if I plug in 0, 0 for this guy, it would end up as 0 is less than negative 2 plus 0, so it would just be that. Is that true? Is 0 less than negative 2? No, it is not true. So because my test point was right here, and it is not true, I'm going to shade away from it. So I'm going to shade this side. Okay, I'm shading everything from here over, which would mean everything not on this line and down, shaded to the downward right, is a solution for this problem. Okay, next, I'm going to look at this guy. I'm going to plug in 0, 0 for him. 0 is greater than or equal to 0 times 3/4 is 0 plus 1 is 1. Is 0 greater than or equal to 1? No. And again, my test point was here, so since it is not true, I'm going to shade everything away from it, that test point. So it's everything on this line and up to the left. So is there any common solutions? Is there anywhere that the two overlap? No. So therefore, there is not a solution for this set. There is no overlap in their shading. Without graphing these are extremely difficult to see. Okay? Now let's practice these on our calculator. Get your calculators out. Press the Y equals button. Let's just go ahead and make sure everybody's on the same page. Go ahead and clear our memory. Okay? So just a reminder how to clear your memory out. Turn it on first. Press second memory and go to the bottom. It says reset. All RAM. Reset. Enter, enter. It says RAM cleared when you get that done. Okay? My calculator is a little bit different from y'all guys', but it all follows the same basic procedures. So we're going to go to our Y equals function. We're going to type in our two equations. First one for me is going to be the Y is less than negative 2 plus 3/4 x. My next equation will be obviously the 3/4 x plus 1. Then you're going to graph them. You should see two parallel lines. If you see two parallel lines, we're on good shape right there. We're in good shape. So moving on from here, your graph should show two parallel lines. Let's go back to our Y equals, now that everybody's checked it and made sure that they have two parallel lines. Let's go back to our Y equals. Tab over here to your far, far left. There is some stuff that you need to hit enter on. Let's get a little closer in on my zoom here. I want to make this shaded to where it looks like a less than symbol. Okay? So my less than symbol will be created with the non-shaded area. Okay? And on this one, it was a greater than symbol, so I want to create a greater than with the non-shaded area. Okay? Less than is on the bottom, greater than is on the top. Great is shaded up, less is shaded down. Alright, here we go. Press graph, and you should see exactly pretty much what we did right there. Okay? They will shade it for you. Such beautiful lines, right? So because there is no overlap, there is no solution. Okay? Because there is no overlap, there will be no solution for this system. So when it says describe the solution set for this, the description of where they overlap is, well, there is no overlap. So they're parallel, the graphs do not intersect. The solution set is the empty set. So it says solution set. Specifically, it asks for a solution set. It is nothing. So the solution set is this, empty set. There's an easier way to describe this. We'll get over it a little bit later. But solution set is sorry, I need to zoom out, is basically the empty set. So the solution set would be this, but when it asks us and there's nothing there, we just say empty set. So this is what I would expect as an answer right there, like empty set. Describe the solution set. If there is no intersection, boom, there it is. It's the empty set. Okie doke. Any questions there before we move on? So on B, we're going to do this one with our calculator as well. So go ahead and get your calculator out. There are two equations. Y is greater than or equal to negative x plus 1. And then we have x plus y is less than or equal to 5. So before I can plug these into my calculator, I have to change this one to a y equals mx plus b. I do that by subtracting x from both sides. So now I have y being less than or equal to 5 minus x, and I plug that into my calculator. So go back into your y equals function, and we're going to put in these equations. Negative x plus 1 is my first one, and then I delete all the rest of this junk. You can clear all these out before you start, by the way. If I just press clear first, it'll reset the whole thing. Next one is y equals less than or equal to 5 minus x. Now, I need to make sure that I change my symbols to where they match with what I need. So this one's a less than. The top one was a greater than. And I should be able to press graph. And it should just show everything that I need. So let's hope that I did that correctly, that we did that correctly. And there should be a little bit of overlap. There is. Okay, let me zoom in on it so you can see it a little bit better. Everybody's graph should look like this. There's a overlap right here. This cross-hatched area is the overlap. Okay, y'all see that? Good. Is anybody not able to get that on their calculator? Awesome. So the solution set here is where both of them intersect. So this is where everything is an answer. So the double shaded or the double crossed area is what we're looking for. It says describe the solution set. So to describe this solution set, we need to go over what our answer will look like now that we've used our calculator to get most of it. So here we would say that the lines are parallel, so it is the double shaded area between the two parallel lines. And you would literally say that. Solution set consists of all points on both boundary lines because it is an or equal to. So it is all points on both boundary lines and all points in between. So basically, because they're solid lines, it's everything right here. But in words, to describe the solution set, it's all points on the boundary lines, and everything in between. Okay? Questions? Let me zoom out again. Yeah, if both of them were just less than and greater than ones, then you would say it is everything in between the two boundary lines, not inclusive of the boundary line, if you want to get more specific. Now, if you had a problem like this one up here, you would say it would be inclusive of the boundary line created by this equation and exclusive of the boundary line created by that equation. Sorry, I didn't show that very well. Inclusive of the one that has an or equal to and exclusive of the one that does not have an or equal to. Okay? So that's the kind of vocabulary you should start getting familiarized with. Okay, so let's write that down, make that a little note. Less than or greater than symbols are exclusive. Less than or equal to and greater than or equal to are inclusive. always be the case. Any questions on that part?
So the dotted line is...
We can add that in there too. So dotted lines go with exclusive. So dotted go with exclusive, and solid go with inclusive. Just like when we graphed them, this one was an open circle and an arrow, and this one was a solid with an arrow. Left or right, it doesn't matter depending on which one you have, but remember that. Alright, so this is where you start actually seeing these. And these can get really interesting on marketing because you can look at profit margins and all kinds of interesting stuff. So example 4 talks about ticket prices. Ticket prices for a Major League Baseball game are $63 for the main box. I'm just writing little notes here. For a main box seat, and $20 for the tier reserved seat. So tier reserved. Suppose you are a CEO of a company and you want to buy tickets for some of your employees. You decided to buy up 30 tickets, so you're going to buy a total of 30, and you are going to spend $1,000. Write and graph the system of linear inequalities to represent the total of all possible combinations of main box tickets and tier reserve tickets that you can buy. So it just wants you to go over all the different solution sets, or all the different solutions that you could possibly buy in combination to make this, okay? Because there's lots of different things that you can do. So first of all, I'm going to establish variables. I'm going to let X be main box. I'm going to let Y be tier. Okay? So I know that I'm going to buy so many of the main box, and I'm going to buy so many of the tier, and in total I'm going to buy 30 tickets. So there's my equation 1. My equation 2 is going to end up being equal to 1,000 because I'm going to buy $1,000 worth of tickets. So my main box tickets cost $63 per ticket, plus my tier tickets are going to cost $20 per ticket. So there are my two equations. Now these ones I would personally rather graph by their intercepts, but again, that's up to you. Okay? So matrix won't work for inequalities. So listen to what the question asks so I can convert these, okay? It says that we need to write and graph a system of linear inequalities to represent all of the possible combinations, okay? So not just where they intersect, we need to find all the different combinations. So what it's saying is, it doesn't necessarily have to be equal to 1,030. We could buy 26 tickets and only spend $900 or whatever. Okay, so just like Taylor said, it would have to be less than or equal to. So here it would be X plus Y would be less than or equal to 30 tickets. And just the same, 63X plus 20Y would be less than or equal to $1,000 because we can't exceed that, right? But we can go below it. So here's really the two equations that we're going to end up solving for. Okay, since we haven't done some by the intercepts, we're going to do these ones by intercepts. So I'm going to let X be equal to 0, and then I'm going to let Y be equal to 0. So when I let X be equal to 0, Y is going to be 30. That one's really easy. And then when I let X be equal to 0, or sorry, when I let Y be equal to 0, X is going to be equal to 30. So that one I can graph relatively easy. So keeping in mind these 2 points, 0, 30, and 30, 0, I'm going to have to start thinking about what my interval will be. So I'm going to start solving on this one too. Again, X and Y chart. Woo. Sharp pencil. 0 and 0 staggered. When I let X equal 0, I need to solve for my Y. So I divide by 20. 1,000 divided by 20 is what? 50. So clearly, 0 and 50 is not going to be in our solution set because we can't buy 50 tickets. But let's see what happens if we bought all main box tickets. So we let Y equal 0. 1,000 divided by 63 is what? Whew, that's a tough one. 15.87, continue for something else, right? So I'm going to get this really close to 16, but not quite. So looking at my numbers here, I have 0, 50. So 50 is my biggest. So what should my interval be here? Tens? Okay, so that'll be fine. So we'll go by tens on all of these. So I'll just mark tens on 2 of those so that we know we're going by tens. Now, let's do our first line. Since they're or equal to, they're going to be solid or dotted.
Or equal to.
They're going to be solid, right? All right, so 0, 30. So we go 10, 20, 30, and then 10, 20, 30. And I can draw that line. Can I have negative
No.
here? No, of course not, right? So everything that is this direction, and this direction, and this direction, are not going to be possible solutions. All right, next one. I'm going to graph 0, 50. So 0 and then 50, 10, 20, 30, 40, 50. So there's that point. And then I have 15.87, which is going to be close to 16. So I'm going to go 10 and then just a little bit bigger than a half there. And connect those 2 points. Okay, so where do we know our solution set is going to have to be? It's going to have to be this direction, right? It's not going to be anything bigger. We already can tell that, but I can run test points to double check. I'm going to run 0, 0, again, because it's the easiest one. So 0 and 0 is 0 less than or equal to 30. Yeah, so it is going to be less than or equal. So it shades toward that point. And it shades everything, right? Next, it's this one. So I get 0 and 0 plugged in here. Is 0 less than or equal to 1,000? Of course it is, right? So it's going to be everything from here down. Now the overlapped area is technically the solution area. So here's where it starts to overlap, and it continues overlapping right through there. But we know something about this problem, and I'm going to zoom in on it so that we can see a little bit better. We know that we can't have negatives, right?
Yeah, so it stops at right.
So it technically is only that little piece right there. A little bit better interval would have made this a little more obvious. Maybe we should have done by 5s. Anyways, our solution set remains the same. It's just easier to see when we go by 5s. So here we go. This is our solution set. So if we were going to describe the solution set, it is all non-negative solutions, because we can't have negative amounts of tickets or negative amounts of money. They're not going to pay us to go watch the game. So it's all non-negatives that are included right here. So this is our solution set. To make it obvious, you should take either a pen or colored pencil or make it dark shaded where your answer is. Okay? And then to make it foolproof, circle it. Okay? That's just for my benefit.